Welcome back. Today we are going to introduce you to SQL, a language for managing relational databases. So SQL stands for Structured Query Language. It's the language that helps us manage and interact with relational databases, which are like giant organized tables of data. With SQL, we get the power to create, read, update, delete data, or CRUD for short. There are fundamental actions you need data management in any database, whether you are creating a new database or pulling out the exact information you need, or updating existing records, or cleaning out the old data from a SQL database. In the world of data, SQL is everywhere. It is the language that helps companies, big and small, keep their information organized, accessible, and ready for analysis. So if you're looking to dive into databases, SQL is your best friend. So all right, so let's dig a little deeper into why SQL is so popular and where you will see it in action. SQL is everywhere in the fields like data science, analytics, and backend development. It's a tool that lets these fields interact with databases efficiently, making it a vital skill for so many tech jobs. So imagine you are in finance, marketing, or engineering. SQL can help you pull out insights, track trends, and make data-driven decisions faster than you can say structured query. Whether you are analyzing customer behavior, optimizing a product, or keeping track of financial transactions, SQL is essential for data management. So now in SQL open doors across industries, making it a powerhouse skill that companies love. If you're ready to open up new opportunities, SQL is the way to go. So there are many ways to install SQL locally. You can visit this website and follow directions for Windows or Mac installation. This is a great option if you plan to do mostly local development. If you have access to your own Linux installation, you can follow these steps. You need to have root access for this installation. If you're using Codebench, you can import SQLite 3 and do all your SQL related work there. So a database is a powerful tool that stores data in organized collections known as tables. Tables are like spreadsheets within a database, where each one contains information on a specific topic or entity. Within a table, data is organized into rows and columns, and rows represent individual records or entries, where columns define the different fields of information for each record. For example, in an employee database, a table might have columns such as employee ID, name, position, salary. And each row in this table would contain details about a specific employee, filling out these fields to create a comprehensive record. So by structuring data this way, databases make it easy to retrieve, update, and manage information efficiently, and enabling organized data storage and quick access to the specific details when needed. So in SQL, creating a table is a straightforward process. Using a create table command, the syntax involves defining a table name followed by a list of columns, each with specified data type and optional constraints. For example, create an employee database is as shown. In this example, we have 4 columns with specific data types. The int data type is ideal for storing whole numbers without decimals, making it suitable for identifiers like employee ID, and variable characters arrays of length n. It's a variable length text type allowing us to store text up to n characters. So that flexibility is useful for columns like name and position. Date stores the calendar dates without any time component, which are also very important for databases to keep track of when the data came in. This is helpful for fields like birth dates or hire dates and things. So lastly, the decimal stores the pieces, precise fixed point numbers, where P represents the the total number of digits, and S is the number of digits after the decimal. This is especially useful for financial data such as salaries, where the accuracy is important. So in SQL, constraints are used to enforce rules on the data in a table. They help maintain data integrity and ensure that the data stored meets certain conditions. A primary key constraint like employee ID in primary key uniquely identifies each row in a table. A foreign key constraint establishes a link between two tables. The unique constraint apply to fields like if a field is like a username, ensure that all the values in a column are unique across the table. The not null constraint, as used, make sure that the column cannot have null values. And the check constraint verifies that all the values in a column meet a specified condition. So lastly, creating an index on a column can improve the query performance by allowing faster data retrieval from the table, especially when dealing with large data sets. So using these constraints, SQL helps maintain data accuracy, enforce relationships between tables, and enhance overall data efficiency. So in SQL, there are several essential commands for managing data in a database. These include select, insert, update, delete. The select command is used to retrieve data from a database. The insert adds new data to a table. The update modifies the existing data. And the delete command removes data from a table. These commands are the foundation of SQL, allowing us to retrieve, add, modify, and remove in a structured and efficient way, ensuring the effective database management. The select statement in SQL allows us to query specific data from a table based on our needs. Let's say you want to select all records to retrieve all the columns and records from a table. We use select asterisk from sales. The asterisk symbol selects every column in the sales table, displaying complete row for each one. Or you can select specific columns. If you want to leave certain columns, we can specify them in the query, like select store product from sales. We'll return only the store and product columns for each one. You can select with a condition, or you can select with multiple conditions. So using these variations of select, we can tailor our queries to retrieve exactly the data we need, making SQL a powerful tool for data analysis and management. So adding records to a data table is a frequent operation. We can specify that we want to add a record with fields and their values by saying insert into the table name, specify the columns, specify the values of the columns, and you can see the example of how we add a column, row, a new record joined row. Imagine now updating records are important because imagine that a bank needs to update records after each transaction. This can be accomplished by update command, where we specify a table name and column name and to a value to a condition. For example, you can say update employees set salary to 65,000 where the name is John Doe. So this is like saying set the John Doe's salary to 65,000. So that's been done here from the old one. And delete removes the record from a database. Caution, you have to make sure you don't delete any records without checks and balances. So once you delete, it should be carefully used to avoid any type of accidental data loss. Now, let's suppose that we are given this data file as a CSV file. We'd like to read this file to a permanent database. CSV file is a snapshot of a moment in time. As new data comes in, this table must grow. If you have a database, then this is possible. How should we develop a schema for this database? So without thinking too much, we may decide to create a table to save store product units sold and revenue information. Perhaps we might add a new field like time to keep track of the transaction times, etc. So let's initialize this database, add 2 new records, update an existing record, and delete records as short. So if you're using a Jupyter Notebook, you could have cells doing specific things like creating a database if it doesn't exist, and creating a table by using the connection.execute, or inserting some product information into the table using connection execute, or updating a product using connection execute and deleting the product. So notice that these are all SQL commands, but we will execute them with Jupyter notebooks with these commands. So how can we filter data? That's also really important, because we can say something like using select, and where we can filter data from a table that satisfies condition. You can say select from all the rows in the employees table for those employees whose salary is more than 50,000. So you could do something like that. And then let's think about these problems now. Let's say we work with the sales database and select sales over 200, or select all sales between 100 to 200, select all records where the unit sold is an even number. You can look at the Qubits comment section on solutions to these questions. Now, finally, we worry about the design problem, where we want to designing a library database where a system where the entries are books, people, entities are books, people, and book loans. So in designing the attributes for each entity, we have each book has specific attributes like ISBN title, author, publisher, year, and the category. And each member has a person ID, name, address, phone, and email. Each loan has loan ID, book ID, and person ID, checkout date, due date, return date. Remember that we design these fields based on what we know, what we need so far, but you can always add more fields into a database later on and populate them. So we can define the relationship as each loan is associated with a book copy, and each book copy can be loaned to multiple members over time. Also, each loan is associated with a member, and each member can borrow books over time. In the next video, we'll go over the code for building these entities and relationship.